Hey guys, welcome to another video. Today I have a very interesting problem for you, which is if you're given an n by n chessboard, how do you place n queens on it such that none of the queens attack each other? And this problem might be a little long because at the end I go through the test cases and modify the algorithm such that it passes all of the test cases. And this step is actually very important in your actual programming or in the interviews. So it'll be very useful for you to know. And also I tell you, like always, what problem I'm going to cover next week so that you can get a head start and try it out yourself before you watch the video. So let's dive right into it. So I'm given an n by n chessboard and I have to place n queens on the board such that none of the queens attack each other.
Correct.
Okay, so if you don't mind, I'll just go through an example to get a better understanding and make a visual out of it.
Yeah, sure.
So let's say I have a board that looks like this. Let's say it's a 4 by 4. 1, 2, 3, 4. 1, 2, 3, and 4. So in this case, if I were to place 4 queens on this board, such that they won't attack each other, let's see what the solutions may be. Let's say the first queen's over here. Then in that case, the next queen will need to be here, right? And actually this, I can't go on because this is not going to work. So what if I put the next queen over there? Would that work? I'll put one queen there, and this is not going to work either. So let me erase this. And so this column's not going to, this row is not going to work, this row is not going to work. So actually this pattern is not going to work altogether. So let me try a different column for the first, a different row for the first column. Now I will place the next one over there. This is the only one that I can place it at. Now I place it over there, and the last one I place over there, right? So this is the solution, but I also recognize that there can be multiple solutions here.
Yeah.
Right? So okay, I understand this. I understand this well now. Perhaps I can implement it just the way that I did this example, which is initially I tried with the first row in the first column, right?
Yeah.
I can either go row by row or I can go column by column. Doesn't really matter. So let's say I go by column.
So you are trying to place each of the queen in one column, right?
Yeah, so I know that in one column there can be just one queen, right? So I can just go column by column because if there are 4 columns and I need to place 4 queens, then obviously there has to be one queen per column. Else it won't really work. Okay, so let's say I start with the first column. I have X over there, right? And let's say I start with any particular row. I proceed to the next column, and then I just start with the first row in that column as well. So for example, let me just do a 2 by 2, for example. I start over here, and then I say, okay, I place it in the first column. Then I check whether this queen is being threatened by any other queens, but there's the first one, so it doesn't really matter, right? So then the next one, I place so I increment the column. So next I place the queen in the first row of the next column, and then I check, hey, is this queen threatened? It is threatened, right? So I say, okay.
So what are the conditions you are checking for if it's threatened?
For if it's threatened, well, the first condition is, well, I don't need to check the columns because it's never going to be in the same column, but I'll need to check the rows. So same row, right? And the next condition would be whether it's threatened diagonally. And that would be an interesting one. Let's say I have one queen over here, right? And then I have a second queen over there. This queen or both of these queens are threatened by each other diagonally, right? So what condition can I use to figure out such a diagonal? So let's say let's figure out the coordinates. The coordinate over here is 0, 1. So the row is 1 and column is 2, right? Coordinate over there is 0, 1, 2, 3. So row is 3 and column is 0, right? So just looking at this looks like I need to take the same amount of steps horizontally as I would need to take vertically, right?
Yeah.
So in this case, I have 1, 2, and I have 3, 0. So obviously the slope would need to be 1,
Yeah.
right? So the slope over here is basically 2 minus 0, or the absolute value of the slope will need to be 1. And 1 minus 3, which is 2 over negative 2, absolute value equals 1, right?
Yeah.
So I can have the second condition saying that, actually I can take this on the other side, so I can basically say that the difference of the x coordinates of the 2 points, so x2 minus x1 should equal to y2 minus y1 and absolute values of both of them.
Yeah.
So if this is true, then it is threatened, right? So let me write that down over here. I'll say x2 minus x1 equals y2. Sorry, I have a bad cough today, so I'll be coughing a lot.
That's okay.
So I have these two conditions to check whether or not the queens are threatened, right? And the algorithm that I'm going through, we call it the backtracking algorithm, where I basically just like over here, I placed the queen over there, and I said, actually this doesn't really work. So after I placed it, I unplace it, right? So I'm backtracking, and I place it over there.
Yeah.
Right? This is not going to work either, so I unplace it, and then I'm done with all of the rows here. So then I go back. So I backtrack all the way, and I say, okay, let me try it over here. And actually, this scenario prompts me to ask you, it is possible, especially in this case, right, that there are no 2 queens that I can place on a 2x2 board.
Yeah.
So in that case, I'll just return null.
Yeah.
Okay.
Yeah. You can
Okay.
make your assumption and return accordingly.
Okay.
Yeah.
Perfect. So I also want to make sure that this algorithm is as fast as possible, right? One thing that comes to mind is, this, I'm putting x's over here. One thing that comes to mind is I have a matrix that is like an n by n matrix with all zeros, and ones are where I've already put queens.
Yeah.
But if I go with that matrix, I'll need to iterate through the matrix every single time, as you'll see when I'm checking these conditions, right?
Yeah.
Because I need to check this condition for all of the queens that I've already placed.
Yeah. You
If-
need to look for the ones in the matrix.
Right.
Yeah.
And if the queen, if the n is really big, then it's not very efficient.
Yeah.
So in this case, then, if you allow me to select my own inputs and outputs, then I can perhaps just take an input of n. So let me say input will be n, and then I can output an array, or ideally like a linked list of all of the coordinates of queens in an n by n chessboard.
Or you can have array of tuples. Like
Array of tuples is okay. Okay.
that's okay.
Let's say array of tuples. And tuples are queens, right?
Yeah.
Okay, perfect. So I also want to point out that in the algorithm that I have in mind as we went through this, it would be more optimal for it would be more optimal for me to use a linked list and not an array, just for obvious reasons, because I'll be backtracking, right? I need to decrease the size, increase the size.
Yeah.
But just for ease of implementation right now, I'll just
Yeah,
use an
for
array.
now you will be using pseudocode anyway.
Right. Okay. Perfect. So let me erase this. Let's go into the actual code. Actually, I shouldn't have erased the matrix, but I'll come back and I'll actually test the code, and that time I'll make a new matrix. So I'll keep this for now. Yeah? So let me say I have a function. Let's call it n queens. Right? And the input will be n. So the first thing I will need to do is initialize an array of my output, right? So let me call it queens. It's an array of queens, and it's an empty array initially.
Yeah.
Now, what should I do next? The next thing I should do is perhaps so I have the matrix. Let me actually form the matrix over here so that it's in sight and I'm not missing anything. 1 2 3 4 1 2 3 and 4. So I initialized an array for queens. Now I won't need to do anything right now. I can just proceed and perhaps have a helper function because I'll be recursively going forward and backtracking. So you'll see what I mean by it. So let me call it function. And what should be the name? Let's say we call it place queen. So let's say I call it place queen. And initially, so let's say place queen takes in the column, right? And that's the only thing. And then it'll be placing the queen on a abstract matrix, right? It'll just be pushing coordinates.
Yeah.
So over here, I'm checking in the column, and now what I'm thinking is that you'll place a queen over here, let's say, and then you place a queen over there, then you place a queen elsewhere, and then you're done with the entire matrix. You've placed a queen such that you have n queens, and you have the solution. Then this will recursively still go on, right? But at every step, we're incrementing the column.
Yeah.
So I will say that if column is greater than or equal to n, just return true. Because at each stage, it will also return a truthy value or a falsy value, depending on whether it was successful to place a queen.
Oh, okay.
Because if it wasn't successful, then this place queen function will know that, hey, I need to backtrack. This track is not working.
Yeah.
Right? So I say, if column is greater than n, you return true. Or what do you do? Well, let's see, what should we do? The first thing we should do is we should push a coordinate, a location inside of our array, right? Now, I will need a while or an if or a for loop to iterate through all of the rows.
Yeah.
Let's say I use a while loop. So I say row equals 0, right? I'll say while row is less than n, right? While it's less than n, keep doing this. So what do we do? Well, the first thing we do is we push it to the queens array. So I'll say queens dot push. And what are we pushing? You're pushing a tuple. Let's say it's row comma column. So I'll say row comma column, right? So I push it. Now what do I do? Now I check whether this particular coordinate, if I place a queen in this coordinate, it's actually safe, right? So let me say if is safe. What do I do? Let's say I give it the row and column to this function, and this function should have access to my queens array, and it'll be able to check whether or not there are any threats at that particular coordinate.
Okay.
All right. So let me give it the row and the column. All right. So if this is true, then what do? Then we recurse. So this basically means that, hey, the thing that we pushed over here, it worked out.
Yeah. So
Right.
Move to next column.
So we can move to the next column. But the only time we actually return true is when the output of the place queen itself returns true, right? Because it'll just recursively bubble up the truthy value.
Yeah.
So I'll say, okay, it's safe. So if you determine that it's safe, then you also check whether the recursive solution eventually yields true. So we'll say and place queen, and we just recurse, right? Column plus 1.
Yeah.
So let me erase this. Okay, so if this is good, then I say return true, right? Now what if this does not return true? Then I need to backtrack. Then I'll say, okay, let me take a step back, and the step back is basically to pop this thing out. So I'll say queens dot pop, right? So now this thing is out. Now what do? Well, we don't have this thing anymore, and we just increment the row, and then we let the while loop continue on. So I'll say row plus plus, right? Yeah. And that's it. So eventually, let's say my place queen function, so it returns true over there, right? It returns true over there. But if the while loop finishes and it has still not returned, then it should just return false. So let me return false, right? So this will be the main function, iterative function, which does the backtracking and everything. So you also notice that I delegated some responsibility to the save function. They'll basically check these two conditions. So let me code that out now.
I have one question here.
Sure.
So when you are returning for, I'm not sure how column is decrementing, because it's possible like I need to move back to previous column,
right,
and backtrack there as well.
Right. So you're not sure how the columns themselves are decrementing when I'm backtracking, right? Let me give you an example. Actually, it'll be a good test, of this particular algorithm.
Yeah.
So let's say I still have a 4x4 matrix, and I'm starting from over here, right?
Yeah.
So my column is 1. So let's say I'm calling this place queen initially. So I'll say, I'm initializing queens over there.
Yeah, you can call it after the function as well.
I can call it over. Let me just call it over here. So I'll basically say if placed, or if place queen. Initially we give the column 0, right? Yeah. If this evaluates to true, basically we are at a solution. Then what do? We just return queens, right?
Yeah.
Okay, so when I call this function, what does it do? We're starting at 0, so we are at that column, right? If column is greater than or equal to n, it is not right now, and row is 0 right now, right? The first thing I do is I push row column, so that's what I did over there, right? The cross. Now I say is safe. Right now it is safe, so it recurses on column plus 1, right? So now it's at this particular column, does the same thing. It's on the first step over here, right? It sees that no, this is not going to work out, it's not safe, right? So it pops it and then increments a row. So we are over there.
So because you are having that recursive call over there,
right?
So it's not done with column 1 until its child returns.
Exactly, yes. So as you noticed, when we called it with 0, it is still over here, right? Yeah. So if this doesn't pass, then it's going to pop
and increment,
and then increment, and then so it's basically even if you're in the second column, it'll go back to the 0th column if it's not able to find the right solution in that track.
Yeah, I see.
Right? Yeah. So let me erase this and implement the isSafe function. Okay, so I say, so this isSafe function is still inside of the nQueens function.
Yeah.
Function is safe. And what does it take? It takes a row and column. Okay. So now we said that these are two conditions that we are checking, right?
Yeah.
Now we need to check these two conditions for all of the queens that already exist.
Yeah.
And those are basically over here. But I also noticed that when I'm pushing the row and column, this is the same row and column that I'm giving it over there, right?
Yeah.
So I shouldn't take into account the last element in the queens array. So I'll basically say, for, so I'm basically iterating, right, over the queens array. So I'll say for I equals 0, I is less than queens dot length in I plus plus. The first thing I check is for the row. So if, no, so now I say, actually, as to my point over there, I don't look at the last element in the array. So I said I should be equal to queens dot length minus 1 or less than queens dot length minus 1, right? So the first thing I do is I say R as in the current row that I'm looking at, or the row coordinate, right, is queens I 0, right?
Yeah.
And C as in the column coordinate is queens I 1, right?
Yeah.
Okay, so now what do? I will check the first condition. I'll say if R equals row, return false, right? And the second condition is if math dot abs R minus row equals math dot abs c minus col. If this evaluates to true, then you return false, right? So now we'll be done with the for loop. At the end, if none of these conditions are met after we iterate through all of the queens in that array, only then do we say that it's safe. So then at the end I'll say return true. Let me TRUE, perfect, right? So this is a safe method. This actually concludes the function. So if you don't mind, let me just test it out with a few different cases and see how it works.
Yeah, that would be great.
Okay, so let me have a test array over here. Let's say this is a 1x1 matrix. Let me test with that. So in this case, over here, I'll start with the 0, right? 0th index, and then in the first, so this statement, it won't return true. It's not met. Row equals 0. Is row less than n? Is 0 less than 1? Yes. So it will say queens dot push row column. Okay. So it places the queen over there. Now it will say if is safe row column. So it'll go over here. It'll say actually I'm iterating, but I don't need to iterate at all because it should be I is less than 0, right? So it's not going to work. So then this evaluates to true because it just returns true. And then we say place queen column plus 1.
It will return true as it.
So that will return true, right?
Yeah.
So this will return true itself. So now as this returns true, this particular condition will say, okay, placed queen is a truly valued, let me just return queens. And at that time, queens is just one queen, right? Now let's say I have an empty array. How would that work? Or I have n equals 0. How would that work? So now if n equals 0, I say place queen 0 and then return queens, and then I say column is greater than or equal to n. Actually, I need another condition to handle n equals 0, because that input wouldn't make sense, you know. So is it okay that if it's 0, I just return, don't do anything?
Yeah, fine.
Okay, so I'll say if n equals 0, or let's say if n is less than or equal to 0, I return, right? Is that
return null.
Or return null? Okay. Less than or equal to 0, return null. And at the time of actual implementation, I'll have some validation for the input, you know, if it's a non-integer, you know, if it's a non-number, then what do I do? Perhaps I just return null for all of those. Or I throw an error. Now let me test this on a 2x2 matrix. So let's say I have a matrix, looks like this. And the reason I'm testing over here is to make sure that it actually returns null.
Yeah.
Right? So I have the first queen over here. It'll go through this process, and we went through this before. And it will say, okay, this doesn't work and that doesn't work. So it will go back and it'll increment, right, the first column. Now over here, column is 1. So it'll say, okay, let's start with row 0. So it'll push this coordinate as the queen, and then it'll say if is safe. This is not safe, right? The absolute value will return false. So it will say pop, and you popped it, and then row increment, it'll go over there. This is not safe because the row is the same. So this will get popped, right? This will get popped. It'll increment the row. Right now we are at column 1, right?
Yeah.
So this while loop ends, so it returns false. So now let's go back to column 0. This one is going to return false. So it'll pop it from the array. So now we have an empty array again, right? So then it'll increment the row. It's not going to continue on with the while loop, and it'll return false itself, right? So eventually this is going to return false. So I need an else condition here to say if place queen 0, return queens, else return null, right?
Yep.
And I think the other scenarios we actually tested already in our conversation. So I'm pretty confident that this algorithm now works.
Yeah, it looks good to me as well.
Thanks for watching, guys. If you like this video, hit the like button below and let me know. And also let me know which problems you struggle the most with, so I can cover those in the next videos. And next week, I'm going to cover the 0-1 knapsack problem, which is a very popular problem in dynamic programming. So hit subscribe and the little bell icon besides it so you get notified, and I'll see you next week.